At the 2022 APS March meeting, the physics community gathers in Chicago and online to discuss new developments and research in physics. The hybrid March meeting program explores a wide range of topics, from nanotechnologies to quantum computers, gravitational waves, and much more. And APS TV is right here, bringing you all the latest from the meeting. Welcome back to the McCormick Place Convention Center and episode 4 of APS TV 2022. As attendees are joining the fourth day of the March meeting in person or virtually, we catch up with some of the APS policy shapers. We're joined by Mark Elsasser, the APS Director of Government Affairs, and Kevin Case, APS Director of Development. We also speak to Carlos Enrique de Brito Cruz, the 2022 APS Bellar Lectureship recipient, to find out more about his lecture. We hear more about some of the universities leading the way in quantum research and innovation. And finally, we ask you, the attendees, what you enjoyed most at this year's meeting. A lot of interesting content coming up there, so stay tuned and join us for our first interview. You're watching APS TV. Mark Elsasser is here now, APS Director of Government Affairs. Thank you so much for joining me.
Thanks for having me.
So if you want to talk to me a little bit about the APS policy priorities right now.
Yeah, so we set all of our policy priorities at the beginning of the year in lead up to our Congressional Visit Day, which happens at the end of January typically. So for the 5 issues our members broadly talked about, they were the federal R&D budgets, policies to improve visa and immigration policies for international students and scholars, programs that would improve teacher preparation to have more high quality physics teachers in our high schools, which obviously is important. And then we had a topic related to climate change, and that's the reduction and monitoring of methane emissions. And the last topic was related to U.S. missile defense systems.
How do you choose? Because there seems to be such a breadth of focus for APS.
The most important thing for everybody to know is that, even though I'm the Director of Government Affairs, I don't set the policy priorities for APS. My boss doesn't set the policy priorities for APS. The members do, right? So we have various ways to engage with our members to take input from them as we determine what the priorities are. We work closely with our presidential line and our board executive committee. We have a advisory committee called the Physics Policy Committee that advises the issues we work on and helps us prioritize. And then at meetings like this, we actually engage with APS members in the APS Village. We poll them, asking them what issues are most important to them, letting them know the things we're working on. But if they have suggestions for things that we might be overlooking, to put them on our issues board, and then we can have those conversations when we get back to DC.
When it comes to lobbying, how challenging is it to translate some of the language, some of the information to people who don't have a background in physics?
Well, that's what APS Government Affairs, right, are experts in. It's challenging, but obviously it's not impossible. And if you look at the track record we've had over the last several years, I think we're doing a great job. One of the things we always want to do is train our members in how to have those conversations, right? And the key for any conversation with a member of Congress is to make it local, right? You want to tell that member of Congress why they should care about it. Why is it important to their state, to their district, to the institution? And what will that policy do, right, for them to improve the lives of their constituents?
Because I feel like those conversations, not just at the government level, but even at the level of friendships or people that others interact with who may be APS members, it works on up, right?
100%.
And you can get people fired up about the issues.
Yeah, you can. Certainly we find ways to get people engaged. I think all the issues we work on are essential to the future of physics, right? But also to the future of the United States, if you think about just global competitiveness, and in the future of the world, if you think about issues like climate change.
You are talking about the future. I want to hear about the future of where your next focus is going to be.
We're a busy office, but we're always looking to improve and looking for new ways to have our voices heard on Capitol Hill. And there's another organization that does research of Capitol Hill staffers, and they figure out how can organizations like APS have the most influence with policymakers. And they do that through surveys of congressional staff. And if you look at a recent survey they did at the end of last year, it turns out that virtual meetings, in-person meetings, meetings with organizational leaders are 3 of the most effective ways, right, for us to have influence with Congress. So right now we're trying to figure out ways, and we have some ideas on how we can have more members engage in these meetings, right? Whether it's virtual or face-to-face.
Some of the members said that COVID-19 actually did open things up, because since they could connect with people online, they were able to connect with folks they might never have in the past. Is that helping you as well?
Yeah, 100%. So if we look at just our congressional visit day from this past year, we had members from 28 states and 53 districts represented in our Hill visit days. I think that was a record.
One other thing for members who are watching this now and they say, I want to help. You talked a little bit about engagement. What are other ways that they can really help in your efforts?
Go to our Action Center. It's on the APS website. I believe the website is go.aps.org/takeaction. If they go there, they can send letters pre-written to Congress on the 5 issues that I talked about. And they can also create a letter of their own. So if there's something we're not working on that they want to engage the member of Congress in, we let them do that. And then APS Government Affairs has an open door policy, right? So my email is on the website. It's elsasser@aps.org. What I can promise, right, if somebody brings an issue to us, we'll talk about it. We'll see if there's something we can do and if it's appropriate for APS to consider.
All right. That collaboration is key for the future. Mark Elsasser, thank you so much.
Thank you. Appreciate it.
Now let's take a look at some of the universities across the globe innovating in the field of quantum science. The Paderborn University's Institute for Photonic Quantum Systems is an interdisciplinary research institute that aims at developing quantum photonics from fundamental theories to real-world applications. Let's find out more.
PHOX is the Institute for Photonic Quantum Systems. It's located at Paderborn University, and we founded it in 2020. We are establishing it at the moment as a new international center where we really want to advance the quantum photonics research. We start from fundamental physics and we go via applied physics, applied engineering, up to the really interdisciplinary research of computer science and also engineering.
The PHOX is interdisciplinary. We have researchers from different fields. At the moment, we have somewhere between 60 and 70 researchers working at quantum photonics technologies.
I'm very excited about the future development of PHOX and joining in these broad interdisciplinary collaborations needed to advance quantum computing, and this we can do together in our institute.
Adopting an interdisciplinary perspective has the potential to open doors to breakthroughs that would be otherwise impossible. At the University of Saskatchewan, Quanta is using pure mathematics to propel its quantum innovations. See how they're working to make the Canadian prairies a hub for quantum science.
The Quanta Center came to life in 2018. It brought together faculty members from the University of Saskatchewan with those at other universities in the Canadian West to bring about an interdisciplinary perspective on quantum science.
I think quantum science in particular is really interesting because it's very interdisciplinary in nature. Many other labs, at least speaking from a student perspective, they have a particular research project in mind they want students to work on. That's something I think really unique about Quanta is you're not sort of pigeonholed that way.
It's very important that in this part of Canada, something like this is happening. I believe myself very, very strongly that we are witnessing a sharp transition that possibly is only comparable to Industrial Revolution.
What I'm very hopeful for is what the new generation coming out of this center, coming out of Western Canada, are going to do with the skills that they learned here at Quanta.
The National Quantum Computing Centre is a new research centre funded through UK Research and Innovation, which is dedicated to accelerating the development of quantum computing by addressing the challenges of scalability. Let's take a look.
The Quantum Computing and Simulation Hub focuses on early-stage technology development across a broad range of hardware and software technologies. The National Quantum Computing Centre focuses on the industrialisation of quantum computing technologies for the benefit of the UK.
We will work together with them to translate some of the quantum computing technology out of the academic lab environment into the National Quantum Computing Centre and into industry.
Our vision is to bring the ecosystem together to tackle some of the really complex challenges, computational problems facing society, but then also ensuring that industry across the UK has the right talent coming into the quantum computing that can really make the sector grow.
We're seeking to build a collaborative working environment where software developers can be co-located alongside hardware developers, and we want to support potential end users of quantum computing from awareness to advocacy.
The second quantum revolution presents unlimited opportunities to transform ideas into radically different technologies that would change the way we live for the better. And one of the institutions leading this effort is Harvard University.
The Harvard Quantum Initiative is something that we've been thinking about in the back of our minds actually for about 15 years. The reason that this is the time is because we have a critical mass of ideas and people here at Harvard.
This is an exciting moment because it's a moment of convergence. It is a tipping point.
The need for a common language and then to really kind of put all the ideas together and evaluate each other's progress is very, very important.
And what we have a specialty in is using atoms arranged at our will in space to create quantum computers.
What we can now do is to use these machines as a tool for scientific discovery.
One of the exciting things that I'm looking forward to is getting the science to help solve problems in society in a way that's more efficient. So that's one of the things that is very exciting about HQI.
The International Center for Theory of Quantum Technologies, based in the amazing city of Gdańsk, Poland, is a strong theoretical quantum information research center with a long historical impact in quantum science. Let's take a closer look.
International Center for Theory of Quantum Technologies is located at the University of Gdańsk. Our mission is to provide worldwide contributions to quantum information technologies as well as their industrial developments and applications.
We are financed by Foundations for Polish Science, which is a huge NGO organization, and all basic funds for our operation are EU funds via a specific EU program.
ICTQT had a great impact on quantum technologies even before it started, because Gdańsk group includes some of the forefathers of quantum technologies.
I decided to do my PhD at ICTQT in Gdańsk because it perfectly combines a high academic level with an international environment.
We are open for international collaboration. We plan to take part in more research projects. We wish to host new PhD students every year.
Professor Carlos Enrique de Brito Cruz, the 2022 APS Bellar Lectureship recipient, is joining me now. Very big honor. I know you're giving the 2022 Esther Hoffman Bellar Lectureship. What's the topic of your lecture?
So in my talk, I will discuss how researchers in developing countries, or in what many times is referred as the Global South, are contributing research results that help the world to achieve the Sustainable Development Goals established by the United Nations. The point of my talk is that even though there is less research happening in the Global South, we have also to remember that less people live in the Global South. About 10% of the population of the planet lives south of the equator. The number of people is smaller, the number of publications is smaller, but still there are results which bring meaningful contributions to achieving the Sustainable Development Goals.
What methods do you use in your research?
It's a challenging thing to assess the research capability across the globe. And the method that I'm using is a method that relies on what they call the science of bibliometrics. This particular database I'm using has more than 85 million scientific articles there. And then by harvesting this database, either by actually reading a small number of things or by machine reading a large number of things, we can classify the contributions and learn about the relative size and the relative benefits of the discoveries in several regions. And we can learn about how different regions have different focal points for their research. And the fact that they are different doesn't happen because one focal point is better than the other. It happens because the regions are different.
Why do you think it is so important to highlight that issue at this year's APS meeting?
3 reasons. One, because there are relevant scientific and technology contributions coming from the South. Second, because many times I see a misunderstanding in the North, supposing that nothing can be done in the South, or very little, or less than what is actually done. And third, I feel that researchers in the South could be more confident about their capacity, and they can find opportunities in research collaboration among researchers in the South. They don't have to always be looking to the North. I'm not against the North, but I'm just wanting to have the South have its fair share of the game of producing science and creating knowledge.
Professor Brito Cruz, thank you so much. We're APS TV, your daily news show featuring interviews and discussions on hot topics in physics from this year's APS March meeting. You can catch us around the convention center, in your hotel room, on the virtual meeting platform, and on YouTube. And you can join the conversation on social media. With new content each day of the meeting, make sure to keep watching. Next, let's continue our journey around the world looking at some of the universities innovating quantum R&D. When you think of Bordeaux in France, you may think of world-class wine. But now, Quantum Matter Bordeaux is proving that they can deliver world-class quantum physics as well through collaboration and by breaking down the traditional boundaries of research fields and institutes.
The motivation of Quantum Matter Bordeaux is to create new directions of research and to push the boundaries of research in quantum matter.
Once we are able to study and investigate nature to a deeper level, what's happening with a highest resolution, we always found something new.
Our experiments are very challenging. They are mixing both experimental and theoretical sides.
We found different projects across all campus, especially to promote new collaborations between different institutes.
The proximity of the chemistry and the physical characterization tool was one of the key points to rapidly progress in our project.
I synthesize new iron-based superconductors. We avoid the use of toxic elements like arsenic or selenium in a quest of developing sustainable chemistry and eco-friendly chemistry.
This is just the start, but we have great hopes for the future, working together to push the boundaries of research in this field.
Quantum cooperativity is often linked to the notion of entanglement, a phenomenon unique to quantum physics. At the Collaborative Research Center Transregio Quantum Cooperativity of Light and Matter, this quantum cooperative behavior is investigated in a large variety of platforms and systems, ranging from trapped atoms, molecules, electrons, to macroscopic bulk materials.
cooperativity in nature, increases efficiency, boosts performance, and increases resilience.
Our idea is to transfer the concept of cooperativity to the quantum world.
Kokolima stands for Quantum Cooperativity of Light and Matter. We have a consortium of 3 universities.
Kokolima joins scientists from quantum optics, but also from solid-state physics.
The goal of Kokolima is to deconstruct quantum cooperativity in order to design a quantum cooperative behavior.
Kokolima is a volcano that is spitting out ideas and bringing it to other fields.
The first thing I noticed about Kokolima was how passionate all the other doctoral researchers are about their research.
The more we know, the more of a larger toolbox we have to make devices and apparatuses based on that.
Hungary has a long history of quantum science. Today, as the world enters the second quantum revolution, driven by the ability to manipulate single quantum objects and use them in applications, Hungary is once again at the forefront with the work of QNL, the Quantum Information National Laboratory of Hungary. Let's find out more.
Quantum science has a long history in Hungary. Eugene Wigner, John von Neumann, Edward Teller, they were born in Budapest. The Quantum Information National Laboratory of Hungary was founded in 2020.
QNL gathers as a network the most devoted scientists in Budapest who want to contribute to this quantum evolution. We develop device components for quantum communication, investigate and produce novel platforms for quantum bits, and investigate quantum algorithms.
We build software technology, programming languages, compilers, and all sorts of useful software tools for quantum computing.
We started the deployment of metropolitan quantum communication links and begin the deployment of cross-border connections.
QNL is just an ideal institute to carry out state-of-the-art quantum science.
The Center for Quantum Science and Technology promotes research on quantum mechanics and its application to critical challenges in physics, chemistry, optics, and engineering. Let's take a closer look.
Hi, my name is Adi Stern from the Weizmann Institute of Science. Together with my friends here, we would like to tell you about Weizmann research on quantum science, about being an international student and postdoc at Weizmann. You know, we are always looking for excellent students and postdocs, and about our new baby, the soon-to-be launched online course on topological quantum matter.
As a postdoctoral fellow in Professor Shahal Alani's lab, I'm helping to develop new scanning probe techniques to study 2D materials in ways unlike any other lab in the world.
Our group studies trapped ion physics. Specifically, we're working on a new trap designed for 50 ions. That's going to be a 50-qubit quantum computer. As a student here at the Weizmann Institute, you have access to leading minds in many different fields. There's also an atmosphere here of creativity and collaboration that is very conducive to doing advanced research.
I'm happy to be joined by Kevin Case, APS Director of Development. Thank you for being here with me today.
Thank you, I'm delighted.
So let's talk a little bit about APS development goals.
Absolutely. You know, one of the things that APS very wisely did in 2019 was sort of an overhaul of their strategic plan, and the underpinning of that entire strategic plan was all about enhancing our financial stability and sustainability. So all of our efforts in development are to support that bottom platform that holds up all of the strategic plan to ensure our financial stability.
And what can you do for that? What's the most important action in that vein?
Sure. Well, there are a lot of different things that we're doing, and one of the things that we're really thrilled about is that this is a membership society of physicists who really want to expand and grow the physics community and support those who want to be a part of it. So we are enjoying wonderful support from our members, but of course we can always use more. And some of the things that we're doing is we're raising funds to to help enhance some of our programs, to support physics students, to help them get through their studies so they can be physicists one day. We also have endowment campaigns that we raise funds for. And to kind of explain it in a nutshell, endowment campaigns really honor the legacy of outstanding physicists. And it's also an honor for someone to be nominated to get one of those awards and to carry on that legacy and to enhance their own career. So we're thrilled about some of the endowment campaigns that we're working on this year.
Those role models, I think, are so important, but we really do have to back up to education. And you mentioned that a little bit, inspiring people to be interested in physics so that the society keeps thriving. How do you do that?
Well, you know, one of the things that this organization has done very well is it's responsive to its members. And one of the challenges that we're trying to overcome is that there is a remarkable shortage of physics teachers in this country. And one of the initiatives that we're raising funds for is known as PhysTech. And it is designed to inspire more teachers to go into the field of physics, but not just to encourage them to get into the field of physics, but then to surround them with the resources they need.
How important is it to get the message out and communicate physics to people in the world, in the society as well?
Yeah, that's an excellent question, and it's a very timely question with vaccine hesitancy, with those who still believe that there isn't a climate change issue. Physicists want to be a part of that solution. So we launched an initiative in January called the Science Trust Project, which is designed to help physicists learn some of the interpersonal skills needed to help communicate in a more comfortable, easy to understand way the science behind issues like vaccines and climate change. And when this launched, it was so popular that we got a great response. In April, we're doing a series of workshops. The first topic will be on communicating climate change. The workshops have filled up, and so much so that we think we're probably going to be adding more. But I think the Science Trust Project is an important way that physicists are communicating the science and letting people know just how important physics is to society.
Kevin Case, thank you so much.
Thank you. My pleasure.
And finally, let's find out what delegates enjoyed the most at this year's meeting.
Being back again after 2 years, delay. So yeah, I mean, it's a great experience to see colleagues, other researchers and the research that's being done.
I think listening to talks and having networking sessions immediately after that has been very useful. That's something you don't get in virtual meetings. Also, you get Zoom fatigue very fast, whereas here you can go and talk and then take a break and then do more talk. So I think overall it's much more rewarding for me.
Actually, I'm really enjoying the fact that it's a hybrid format because there are a huge number of parallel sessions. And so you used to have to choose which talk you want to go to and whether you wanted to watch a talk or talk to this particular person more. But in so many of us are actually just networking here and then we'll catch up on talks later.
I think it's meeting people in person, especially the genius people who are doing science. And I mean, I'm a third-year graduate student, so it's a huge opportunity for me to meet these all the big names in the science society. And yeah, meeting people in person after a long time, that's what I'm enjoying most. Yeah.
That's it for our fourth and final day here at the 2022 APS March meeting. And it's been great connecting with all of you in Chicago and virtually. We hope you enjoyed watching our shows. And don't forget, you can catch up on anything you missed online on the virtual platform and on YouTube. We hope we'll see you again at the 2023 March meeting in Las Vegas. Until then, goodbye.